and we're getting to graphs of rational functions. So we're putting all of this good stuff together and learning one new concept. Can you analyze and sketch graphs of rational functions and their asymptotes? Simplify the function. Name restrictions. Find and plot the y-intercept. Find zeros. Plot x-intercepts. Find zeros of the denominator and sketch the vertical asymptotes. And we're going to plot holes with open circles. We're going to do all of this together. Find and sketch any other asymptotes. That will be our slant asymptotes that we're doing today. Plot 1 point between and 1 point beyond each x and vertical asymptotes. We need a couple more plots. So once again, plug in numbers. Plug in numbers. And it says use smooth curves to complete the graph between and beyond the vertical asymptotes and other points. Now, all of you should know how to graph this because of our parent function time. So you should know your rational parent functions now. So I'm going to give you a second to graph it. Push pause. All right, so let's go through the things we know. The first thing we know is this is going to be graphed in a Cartesian coordinate system with an x and y axis. We also know because if I make the denominator equal to 0, we can find what we call a vertical asymptote. Our vertical asymptote is at the line x equals -3. And if we start plugging in some points, they told us to plug in the x, they said to find the y-intercept and the x-intercept. So the x-intercept is when y is 0, and the y-intercept is when x is 0. So let's find if I plug in 0 here, I get 1/3. So when x is 0, y is 1/3. That's about there. And they say to plug in a few other numbers. How about -1? What happens when I plug in -1? I get 1/2. It's a little bigger. What about -2? I get 1. So my gut guess, and because I'm looking at the graph, is it's going to look like this. Oh, we didn't talk about those horizontal asymptotes, but because the n is smaller than the m, there is no horizontal asymptote. Let's try some more numbers. Keep plugging, plugging. -4. If I plug in -4, the equation was this, 1 over -4 plus 3. That's going to be -1. And if I plug in -5, I get 1 over -2, that's -1/2. And it looks like this is going to be the same type of pattern where it goes like this. Rational equations, how'd you guys do? So this one might be more challenging, but it is always good to do what they say. Again, we're going to graph this, and let's state the vertical and horizontal asymptotes. The vertical asymptote is going to be when the denominator is equal to 0. Well, what would make the denominator equal to 0? When x is equal to -1. So at -1, we have what we call a vertical asymptote. A horizontal asymptote is my n over my m. Now this one's a little mixed up for us because it's not written in descending order, so we have to know that we are still looking at the coefficients of this. So y will equal 2 over 1, which is equal to 2. So notice that at y equals 2 is where we have our horizontal asymptote. Now, in order to graph this, again, we're going to plug in numbers. And when I plug in numbers, for example, If I plug in 0, I get 3. Okay, and then when I plug in, let's plug in -3. What happens when I plug in -3? Let's see, I have 3 plus 2 times -3. 1 plus -3. Well, this will be 3 plus -6, which is -3 over -2, which is 3/2. So it looks like this is -1, -2, -3. This will go up to 1/2. So my gut says if I keep plugging in numbers like -2, this is going to be the graph here, and this is going to be the graph here. The last question it says is to state the domain. Well, I know the domain is all real numbers, except x cannot equal, in this case, x could not equal -1 because of this bottom denominator. All right, we're going to take a look at this one. This one's a little different because if you notice, we can factor. So let's factor the top and the bottom. This can be x plus 3, x minus 3 on the top, because x squared minus 9 can factor. And this is going to be x minus 3, x plus 1 in the denominator. So what we've created here, where the x minus 3 is, this is called a whole. So I know that when x is equal to 3, we're going to set this x minus 3 equal to 0. When x is equal to 3, that is where we have a whole. Well, we need to plug that number back in. So I'm going to plug that back into my new equation. So I'm going to rewrite my equation as f of x is equal to x plus 3 over x plus 1. When I plug 3 in, I'm finishing the whole. When I plug 3 in, 3 plus 3 is 6. 3 plus 1 is 4. I get 3/2. Now, let's look at the vertical asymptote. Where is the vertical asymptote? Because these wholes canceled out, the vertical asymptote is now just right here in the denominator. So x equals -1 is the vertical asymptote because it's of the simplified denominator. What about the horizontal asymptote? Well, remember, we have 1 and 1. We also have some more 1s. The coefficient is 1. The exponent is 1. So what is the horizontal asymptote? The horizontal asymptote will be at y equals 1 because of the coefficients of n over n and m are equal. So I'm going to start to graph what I know. I'll start with the vertical and horizontal asymptotes. The vertical asymptote is at x equals -1. Horizontal asymptote is at x equals 1. And I know there is a whole at +3 and 1/2. So I know right here there is going to be a whole. Now, if I plug in some more, let's find the y-intercept. The y-intercept is when x is 0. That's just going to be 3. So that point 0, 3 is going to be graphed. Well, this was 1, this was 2, this was 3. Because I know what I know with rational equations, these are functions, this is going to look like this. Now we have to graph that whole. Very different concept here. Okay, if I was to plug in other numbers, I know that this will be graphed as well. And there we have our graph. We have our vertical asymptote, our horizontal asymptote, our whole. Very good. Let's go ahead and find the x-intercept too. Remember, the x-intercept is when y equals 0. What was the x-intercept when y was 0? So if we plug that in, the x-intercept was actually a -3. So 1, 2, 3. I kind of graphed that. Good job.